So you got a problem. No worries, they make a pill for that. But as far as the car, what I'm gonna show you is gonna help you across all cars. It doesn't matter when they're made, how old they are, in the future. What I'm gonna teach you is going to translate to every car you will ever touch. Ever. 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 If you ever seen my CAN data bus video, you know my artistic skills are not the best. So feel free to judge. I'm going to draw. All right. Ready? I don't care if it's a 1950s, 2000s, 2020. Every car has wiring. Let me see how that looks. Wiring. Okay. Every car has connectors. Every car has pins. Every car has power, indicated by that. Every car has ground or earth. Earth is ground. Very clever how they came up with that. Every car has power or circuit protection, aka the infamous fuse. Hate that word. Now that you know this, the question is, what do you do with this? All right. Got it? You can always rewind and pause. Okay. I don't care if it's a map sensor, O2, power, window, motor, washer pump. Is my voice annoying yet? Hope so. I want you to remember this. Doesn't matter what it is. Okay? All right. This saves me time of editing text and fancy stuff. So let's go with a map sensor. And let me get my backup pen. Map sensor. All right. Google a map sensor. Just see how it works. You'll see there are 3 wires. All right. So let's say a map sensor is going to be a round sensor depending on the car and a square connection. Inside are 3 terminals. One is positive, one is negative, and one is signal return. Okay? Let me get that in there. Positive, negative, signal return. On that map sensor, there's going to be a connector that plugs into it. That's going to have 3 female pins. Now, when you look at most diagrams, it might show this and then that. That means male, female. So you know which side of the connection has what. All right? It would look like this in a wiring diagram. And then it would show wiring like this. Okay? Indicating that this is the female side and that's the male side. So, terrible. From this connector, it may go direct to another connector, which is now the ECM. Okay. What are the points of failure? That's what I want you to remember. points of possible failure. Okay, so the sensor can fail. The pin inside the sensor can bend. If you unplugged it and plugged it back in, or if you replaced the sensor and you didn't do it right, the pin can bend. So we got a bad sensor, a bent pin. We have a poor connection. It may not be seated all the way where it's not snapped in. The female pin cannot have tension. Tension is a mother. So let's see if I get this to zoom here. Here's how a female pin looks. It's just an opening. It could be round, rectangular, or square. Inside, there is a bent piece. That is what scrapes when you plug in the male side. If that loses tension, that is when you get intermittent, meaning once in a while, issues where, let's say you go over a bump and now it works. Then you go over another bump and now it doesn't work. Or the weather changes it because things expand when they're hot and they contract when they're cold. The inside tension could be bad. How do you fix that? You either replace the pin, or depending on what you're working on, you can go from the back, hey-o, and pry it to get more tension, okay? Or you can take the male pin and gently bend it so when it goes in, it's a little crooked. You've all done this with electrical cords, your vacuum cleaner, your lamp. You step on it and it bends, right? So now you got to bend it back straight. Same thing. And if you haven't done it, sorry, I must be the idiot, but points of possible failure. Map sensor, the pins, the connection, the tension. Here's the big one that gets everybody. Number 5, the location of the wires. It does matter. Let's say you just bought the car. There's an issue. You put a sensor, didn't fix it. Must be the computer. Put a computer, didn't fix it. Now what are you going to do? You just replaced everything there is. The connector could have got damaged. A pin could have got ripped out. Somebody fixed it and they put the wire in the wrong slot. Every connection is numbered. Either 1 through whatever, 20, 30, 40, or they're lettered, A, B, C, D. Like GM likes to letter them. Other manufacturers like to letter them. Benz and cars like to number them. On the face of every connector is a number. I'll show you because I got my test subject. So the position of the wiring, okay? Number 6, the integrity of the wire. You can have all right. Here is, I'm going to guess here, 14 gauge. The lower the gauge, the thicker the wire. I want to say this is 14, maybe 12. All right. Now, this is how it looks inside a wire. A bunch of smaller wires, all coated, okay? This is a good connection. It allows amperage to flow through and it will have good resistance, okay? Come on. This is a bad connection, but it will show voltage and it will show resistance being good. However, when you go to operate the item, it will not have the amperage flowing through it to perform the action. This happens with drivers' doors, any door. It happens with doors. When you open the door, the wiring in the door jamb flexes and opens and flexes and opens and flexes and opens. And over time, it breaks in between and the door may work when it's open. It may work over a bump. It may only work when it's closed. Trunk hinges, hood hinges, anything that wiring has a place to bend and move and wiggle, it'll break inside. So you can ohm and it would show good resistance. However, you can show voltage with a test light and it would be like, yeah, I got 12 volts. Voltage is the push. Amperage is the power that actually works the items. Resistance is how long it takes from point A to point B for it to get there, or continuity, meaning do I have connection? Do I have continuous connection from end to end, right? So you can have poor or break in the wiring. So let's say your driver's window is not working. The locks are not working. The door chime is not working. The window motor, or I'm sorry, the mirror motor is not working. The turn signal on the mirror is, nothing on that door is working. Should have just said that. You check the door control module, they're called DCMs, or DDM, depending on the manufacturer. So you check the door control module, you got power and you got ground, but it's still not working. Must be the module. You put a new module in there, still ain't working. Because you have a broken wire in the jam that allows it to have voltage. So it shows good on a meter. It shows good with the test light. So what I tell people is, if the door control module only needs power and ground, disconnect the connector and run your own power and ground. You're going to supply the power and ground, okay? From the battery, all right? If you can do that and it comes to life, the wiring is your issue. So that's a test that I do, is can you power it yourself, okay? If you see my scanner video, I show you how to activate stuff with the scanner. You can do that if you don't have a scanner. You just apply power and ground. Everything works off of power and ground. If it's not supplying a signal on its own, like a wheel speed sensor or a crank sensor, then it's going to get supplied power and ground, like a solenoid, a switch, a motor, something that actuates, right? So let's recap, because I don't want you to forget. You can always rewind and watch it again. I don't want you to forget. Bad component, bent pins, poor connection, loose tension, misplaced, miswired connector. That happens so much, it's not even funny. It's one of those things. I have to make a list of what I got to ask people, because sometimes I forget, is the wiring in the right cavity? I'll tell people, let me say, I'd say, hey man, check pin number 1. It's a green wire. Check it for power. Pin number 4, it's a yellow wire. Check it for ground. And then they come back and say, ground is good, but that wire wasn't in that one. It was in pin 6. You were wrong. Whoa. Whoa. It's in pin 4. So if you're telling me it's not in slot 4, it's in slot 6, you know, one thing I want people to know in cars, everything means something. Everything that works is a symptom. It's a hint to what's happening. Everything that doesn't work, it's a hint to what's happening. How the car operates, doesn't operate, same thing. It's a hint. So everything means something. My car doesn't start. Cool. That can mean anything. But the windows work. Great. Sunroof works. Awesome. The dash comes to life. Perfect. I can shift it out of gear. Even better. Turn the key, nothing happens. Bad starter. Okay? Something like that. It makes it easy when you walk down the path and just think out loud what is supposed to happen at different points. All right. So back to integrity of the wire. Now we're back on this side. Loose tension, misplaced wiring. The connector's not seated. The pin is bent for the module. All right. That's it. That's it. That's everything you need to know about everything you'll ever encounter. When does it get tricky? It doesn't. It doesn't get tricky. When does it get harder? It doesn't get harder. Okay. So here is another tip. All right. Depending on where your problem is at. So if it's in the engine, you're most likely going to have the sensor, and then it's going to be one connection, and it's going to lead to the module. okay? If the module is not located on the engine and it's located in a box, then you're going to have, this won't be a module, this will be a connector. They call it a separation connector. So all the wiring stays on the engine. Remember back in the day, you had to take off every wire to the engine and lay it to the side? Well, now they just made it where the wire stays on the engine and you unplug the engine and that's it. So now you have a connection for the engine, okay? Engine, body. And then this wire leads to the module. So all you have is one extra connection. I'm sorry. Yeah, one here, and one here. So now you have 3 connections you got to check. Same principles, same ideals. Wires in the right spot. Tension on the pins. Pins are not bent. Connector is seated. Wiring is good. Connection on the pins. Pins are not bent. Pins have tension. Wires are in the correct spot. All right. Everything in the car operates off of power and ground, except maybe a crank sensor, maybe a wheel speed sensor. Something that is magnetic will generate a pulse to the module. Those are the only things that you really can't check power and ground to because they don't get power and ground. But you got to know from like All Data or Mitchell or Identifix, something like that, you know, wiring diagrams. You got to know the wiring diagrams and how that sensor operates, you know. So super easy. Google helps a lot. I hate Googling, but when you Google for how something works, that's different than Googling how to fix my car, because something only works one way, you know, and you'll generally get the right idea. So let me go even further, because all I'm doing now is being redundant and showing you that nothing gets trickier. Okay. General Motors engineers, when they're done smoking crack, they go and they wire up the truck. Here's how they wire it up. So they'll go from the fuse box. Okay. From the fuse box, you have connections underneath. From those connections, it will run to the firewall. And if you don't know what a firewall is, it's basically the sheet metal between the engine bay and your feet. That's it. That panel we call firewall. There's usually a fat ass connector that goes from the body through the body, or depending on the car, there's just a big hole and the wires run into the interior. So now you have a firewall connection, male and female, okay? Male pins, female pins. From that connection, it'll run to a dash fuse box. Guess what's here? Connectors again, pins. God, I'm terrible at drawing. From the dash fuse box, it will run to another separation connector. Because from the dash fuse box, if people wanted to remove the dash, or when they're assembling the cars at the factory, they just put it in one unit, so they can't run all the wires. So basically everything's assembled on its own, and then a robot puts it in, and they just snap everything together. So now you have another separation connector. This may lead from the driver's side to the right rear of the car. So now these wires, doesn't matter how long, are going to run to another separation connector, because you may have a quad cab, a single cab, a crew cab, or extended cab. So everything is different based on the body. Two-wheel drive, four-wheel drive. A two-wheel drive has one wiring harness from the engine module to the speed sensor. But if you have a transfer case for four-wheel drive, they add an adapter harness to the speed sensor. So now you have an extra connector and wires, right? So then we're running from here to the right rear door control module. What changed? More work for you. That's all that changed. Nothing is different than connections, pins, tensions on the pins. Are the pins bent? Is the connector seated? Is the wiring in the right slot? Another one, repeat over and over and over. Do you get it? I know you got it. I know you're like, shut up already. Pause, fast forward, next video, show me some squirrels, right? Something. I mean, that's it, guys. that is it. I don't know what else I'm missing here, except, okay, the only thing I'm missing is fuses. Fuses. I'm gonna take it to the car for that one. Okay. This is my guinea pig. All right. Same thing applies here. In those slots, you can see the two teeth that actually grab the relays when you put the relays in. All right. Same thing with fuses. In the slots for the fuse, you can see it back there. Let me zoom in. See it? In there. Okay. There's teeth in there. You have to make sure that they're okay. All right. You got to make sure they're not bent. Fuse boxes are a little bit different. The only thing that really happens to fuse boxes, depending on the model and car, is they can burn. That's what I'm leaving out. All right. So let me show you this relay. Look at, see the scrape marks? That's how you know it's biting, the scrape marks. All right. Look at them, nice and shiny. If I were to pull this out and they had black burns on it, you know what that means? The connection is poor or it just heated up over time and it's melting in there. All right. A heated connection is a poor connection, just the same. So that's one thing. So look at this connector right here. I'm going to show it. So everything is numbered too. All right. See on there, M12 or M1Z. That's the connector. That's the connector location. Let me unplug this. Pain. Let me try this one. There we go. All right. Here's the connection. Okay. Notice there's a part number on there. Almost all connections for cars have part numbers, most of them. All right. Look at the face. See them? 1, 2, 3, 4, 5, 6, 7. All right. See them on there? Let's see if we can zoom. 1, 2, 3, 4, 5, 6, 7. They're numbered. All right. Every color wire is different. Everything has a stripe and a color, or just a straight color. Or some older cars, they have a color and they have circles of different colors on the wire. There's the connection in the fuse box that it mates with, the male. All right. So you got to make sure they're not bent. Make sure they're straight. Okay. All right. That's the one thing I forgot to mention is high amperage wiring, like a starter solenoid wire. Well, it's not really that. It's like a starter solenoid wire, an air compressor for suspension wiring, a power window motor, things that work with a bunch of juice behind it. The pins can burn. So no different than what I just told you. You can check for power and it'll show voltage with a voltmeter. It'll show power with a test light. When you go to activate it, nothing will happen. That's why you have to physically inspect. All right. Now there's one thing called refreshing the connection. This happens with usually old cars, 10 years or older, but it can happen with newer cars if they're stored poorly or they have water leaks. God, I hate talking like that. If they got water leaks, what happens is you get corrosion on the pins. A super slight film that builds up over time and creates a poor connection. If you've ever had somebody say, or if you've ever done it, the car was doing this, the code was for this, I unplugged it, and I plugged it back in, it's been working ever since. I don't know what it can be. Yeah, you do. You just cleaned it. You cleaned the connection. So some things we do is we unplug it and plug it back in a bunch of times, right? Or you can take pins and clean the connectors. They actually make super small sandpaper covered pins, or it's like felt and you put a cleaner on it and you slide it in and out and clean the terminals. But that's it, man. That's it in a nutshell. When I diagnose a car, I go through every single step, every single time, and you find the issue. There's only so many things it can be, all right? It is just that simple. All right, so in this Mercedes auxiliary water pump, these pins are round, all right? Notice there's a slit in that female. You can actually crimp that a little bit tighter, but that's can be a poor connection. And if you notice here, see the green? That's corrosion building up right there, all right? One thing you have to, many things, I'm gonna stop saying one thing. Another thing you have to know is that on these engines, almost all newer engines use advanced magnets and phasers to move the camshaft. Because they work in oil, the oil can actually seep through the connector. Look at this. Yeah, love it. See the oil in there? That came through the body of that, all right? See this adapter harness? What did I say? Pins, terminals, location, connector. Seated pins, terminals, wires. All right. Mercedes added this. You know why? Because they know about the oil leak. I got dirty. They know about the oil leak. The oil will wick into the wiring harness all the way to the engine control module and fill it with oil. Anything those wires are connected to will be coated with oil and can cause the engine to run bad. In the newer Benz, it's terrible. These cars are being totaled for $10,000 to $12,000 worth of work for wiring harness, engine module, every sensor and solenoid and injector on that engine. It's insane. One thing I forgot to mention. Back to the eraser board. Right. One thing I forgot to mention. Okay. Let's talk about a multi or a shared circuit. A couple different ways they do this. They can have a connection, and in this connection, if it's positive or ground, doesn't matter, there's going to be two wires. Okay? That can happen. All right? I'm sorry. No, that's wrong. That's wrong. There can be two wires from the same pin. They can be soldered and pressed into the same pin. Or it can have a solder joint or a Z-splice. It'll come here, and in a wiring diagram, you will see a big black period. Okay? Okay? All right. What this means is this fuse or engine module, whatever powers that circuit, it goes to a splice. So now the map sensor gets 12 volts. There are usually 5. Don't judge me. This is example. Map sensor gets 12 volts. Let me see here. Yeah. Injectors for bank 1 to the 6-cylinder. Okay. So now you're sharing with the map sensor, all 3 injectors on bank 1. Then you got the cam sensor. Okay. Then the same splice is going over to crank sensor, which is not gonna, but just example. And then we're going to injectors again. Okay. Car cranks won't run. You've got a fault code for open circuit or shorted to positive at the crank sensor, cam sensor, all the injectors, and the map sensor. Man, I can't believe I got to replace all those. You don't. You either have a blown fuse or one of these is shorted internally right to ground. So it's killing the voltage input. If it's fused power, the fuse usually pops, all right? If the engine module, ECM, is outputting that voltage, it's not going to pop any fuse. It's just going to kill the voltage. So you'll have 12 volts coming out, but once it gets out here, it shorts to ground. So now the ECM doesn't see a return. It usually be looking for a return. But the one thing I forgot is the Z splice or solder splice. So if you're looking at a wiring diagram and it shows a period, it means that you're sharing that with other circuits. So you need to verify. So let's say, here's what happens all the time that I deal with in Mercedes audio issues. All right. Mercedes audio issues, which can be the same for any manufacturer. Radio, CD changer, navigation, telephone. My drawing is horrible. Satellite radio, and let's go for voice control module. All right. All of these have their own power and ground. All of these have their own connections, wiring, yada yada. When you turn the radio on, it sends out a wake-up signal. Okay, it sends it out to either a splice, or they call it a shorting bar. It's no different than a CAN data bus bar, depending on the manufacturer. All it is a spot to where this wire connects to a bar, and every other wire that comes out of here leads to something, okay? So, you turn the radio on, it sends out voltage, which is now touching everything. They all wake up, except voice control module is not doing anything. I say, hey, JJ, I need you to check the wake up signal. Well, I know I have it because these wake up and they're all shared there. I don't want to hear that because you didn't check if that pin is connected. You didn't check the integrity of that wire. You didn't check if that wire is connected properly to the voice control module. You didn't check if that wire is in the correct slot of the connector to that control module. You didn't check if that female portion has tension or if that male pin on there is bent or if it has corrosion, okay? Nothing different, nothing different. So, that's it guys and gals and kids and family. The component, the pins, the connector, the female side, the tension, the cleanliness of the pins, the wire, is it in the right slot? Is the wire damaged in any way, shape, or form? Does it have great continuity from one end to the other? Does it have voltage? Does it have amperage? Does it have ground? And you just keep doing that from place to place to place. And that's something that is overlooked a lot. And I hate saying the phrase, don't assume, because it makes an ass out of you and me. Where in reality, in the car world, when you assume, 9 out of 10 times you're right, but it's that one time that really bites you in the ass. So by following my handy dandy drawings and understanding that It doesn't change. I can put anything in these boxes. Nothing changes from what I just showed you. Connections, wiring, pins, terminals, locations, integrity. Something as simple as that. The hardest part that you guys are going to have an issue with is finding good quality diagrams to know what you're looking at is correct. So I ask you to tread lightly with the Google searches and the wiring diagrams. You're almost better to go to like All Data or Identifix and pay for a couple days subscription to get wiring diagrams, or find somebody like myself that can help you with wiring diagrams, or find a service CD online. Information is out there. Just be smart enough to know that you're looking up the right information. And I can't stress enough that I've worked with guys in the dealer for years on end that still don't do the basics of stuff like this. They overthink it. Don't overthink it. Everything has the same components or the same structure. There's a power source, there's a ground source, there's connections in between. So just follow the path over and over and over again. So actually, I'm sitting here editing this video, and I did remember exactly what I forgot. What I forgot was, when are you going to use what I just informed you of? So, no whiteboard, I'm going to purple paper. This will be quick, hang tight. All right, fuse box, power window motor. Let's say you have no power at the power window motor. You used your meter and you check from positive to ground and you got no voltage. You check the fuse, you got 12 volts at the fuse. So now we know there's a problem between the power window motor and the fuse. That's when you need a diagram to see where the wire goes, to what connector, if there's one or two. Okay, then you could do one of two things. You can check for voltage at this connector to see if you still have it. If you do, then you check the connector at the other side. If you do, and you don't have it here at the motor, you know that the problem is somewhere in this wire. So what you could do as the fastest route, if you don't want to go through all this, which we don't do in the dealer, we do what's called a wire overlay. If you have power at the fuse and you don't have power at the whatever it is, we'll say power window motor, you don't have to diagnose all this. Take your own wire, you cut this wire at about 6 inches, so you have plenty of time to repair it. You run your own wire direct as a test. Doesn't have to be perfect, just run a wire. Don't even care how long, short, ugly, doesn't matter. Connect it up. If everything's good, now you're gonna run the wire the best way you can in the car. That's what I'm missing, the wire overlay. So if you didn't want to go through every step of checking them, that's fine. In the dealership, we didn't get paid to trace the wire. Warranty would not pay us that time, so they came up with the wire overlay method. So we would run our own wire from the power source straight to the item, see if it works. If that's the problem, you don't have to find where the wire rubbed. It doesn't matter. Just cut from the power source that you know is good, cut to where it's supposed to go. That way that wire's dead. It doesn't do anything anymore. If you want, tape it up, mark it what it was, whatever's cool for you, and then run your own wire. And you can run it the same way, which sometimes it's not beneficial. We didn't get paid to tear up the carpeting, the door sills, the headliner to run a wire. So we would just run the wire the safest and best way we could. And then I would put notes on the repair order, ran the wire, here's where it went, and then I would tape up the wire and mark what it was for. So let's say you were working on the car, you come across this wire that's not in the wiring loom, you don't know what it is, there'd be a piece of tape on there saying ran from connector pin to connector pin, so that way it was easy to diagnose. That's what I was missing, the wire overlay. It saves tons of time. So that is when you would use everything I just showed you in this video. If you go right to the power source and you have power, but you go to where it's supposed to work and there is no power or ground, either one, then you would proceed with the rest of the steps that I did. But it would be different for, no, it's not really, it'd be the same thing for a sensor. You know, you don't have to go through all the connections and stuff. You can run your own wire overlay or whatever, but that was it. Thanks. To wrap up, appreciate you guys. Thanks for watching. Really appreciate that. Throw me a like, please subscribe, hit the notification bell, and comments, you know, let me see what if this was helpful, how it helped you, what you didn't like. My wife has no problem telling me what she doesn't like all the time, but appreciate you guys, and see you next time.